In this video, we'll see how to create singleton object of a class. So, first of all, we'll see what is singleton. A singleton class is a class that can have only one object at a time per JVM instance. To create a singleton class, we need a static member of a class, private constructor, and a static factory method. So here I have created eager initialization class. It is having an instance variable as eager initialization type, and we have assigned it a new instance of the eager initialization class. We have created private constructor of the eager initialization class, and we have a static getInstance method which will return an instance of the class. So the eager initialization implementation of a singleton pattern will have a disadvantage that it will create an instance of the object whenever we will not require it. So as we know, the class initialization occurs when the first time we use one of its method or a field. Suppose say we have a test initialization method and we'll call this test initialization static method from outside this class. So it will create an instance of this class, but as it is not, as will not require the instance of this class, but it will create. So to avoid this eager initialization of the class, we can implement the singleton pattern with a lazy initialization. So for that I have created a lazy initialization class. So in that class we are not assigning the value to the instance variable. Instead of, we are assigning or creating an instance of a class inside a getInstance method only once if the instance is null. So here in the getInstance method we have checked that objects.is null of the instance, and then if the instance is null we are assigning instance with a new object. Here in this case is the new lazy initialization, or else we can return the already created instance of the class. So this lazy initialization implementation will have or will break the singleton design implementation in multi-threaded environment. Suppose say we have multiple threads which are calling the getInstance method, and for the multiple threads the object.is null instance, this method will be true and the multiple instances of the class will get created. So this will break our singleton implementation. So to avoid this multiple creation or the access of the multiple threads to the getInstance method, we'll need to make the getInstance method as a synchronized. So we'll see how we can achieve this. So in thread safe initialization method in class, we are making this getInstance method as a synchronized. So by making whole method as a synchronized, it will have a performance overhead, because if the multiple threads simultaneously call the getInstance method, or any one thread will call the getInstance method, the thread will have to wait if other thread has acquired the lock. So if the instance has been initialized once, is initialized, we'll not need to check for the synchronization process. So to avoid this overhead, we'll only make the instantiation of instance as a synchronized. So for that, we can use a synchronized block. For that, I have created a double check singleton class. So in this, we are only synchronizing the object initialization or the instance variable initialization process. So here we'll check if object dot is null instance, then we'll make the synchronization on the object of the class, that is double check singleton, and again here we are checking the object dot is null instance and then assign a new instance to the variable. So here we'll need to check 2 times if the instance is null. So this is the process is called double checking. So we'll require this double checking because of if the multiple threads call this get instance method, and if 2 of the threads check the condition for the first time the instance is null, and one of the thread will acquire a lock, and if will not write this if condition, the one of the thread will acquire the lock and it will create an instance and assign it to our instance variable. Now the second thread which is waiting to acquire the lock will acquire the lock, and it will again create another instance and assign that instance to our variable. So the 2 variables or 2 instances or the multiple instances of our class will get created. So to avoid this, we'll also need to check inside the synchronization block if the instance is null or not. So through this, we can avoid the singleton design pattern break in the multi-threaded environment. There is also another way we can implement the singleton design pattern, that is called the initialization on demand, and it will use a nested static class to hold the instance of our singleton class. So in this scenario, I have created a singleton class and I have a new private static class as a lazy static holder, and in this lazy static holder I have created I have a field singleton instance is equals to new singleton. So here we are assigning an object of our outer class, and in the get instance method we are just calling just accessing the instance variable through the nested inner class dot instance, because both of them are static. So here, as we know, the class initialization occurs the first time we call its method or field. So in the get instance, we are calling or trying to access the instance, the field instance as a field which is static, and when we call the instance field, the lazy initialization holder class will get loaded, and at that time it will initialize the instance variable and it will return the object. So the static initialization or the class loading process and the static variable initialization process is handled by the JVM, and that is threadsafe. So this is the another threadsafe implementation of the singleton pattern. So there are multiple scenarios. In that case, the singleton implementation will get fail. So one of the scenario is the clone. When we do the clone of our object, it will create the same copy of the object. So to avoid clonable, we'll need to override the clone method, and in that we'll need to throw clone not support exception. So through this way we can achieve our singleton pattern. So there is another scenario in which the singleton implementation will break is the serialization. So in serialization, whenever we implement the serializable interface, we can override or we can implement two methods, the write object and the read resolve object. So in write object, we'll write a mechanism to store our object to the serialization. So to avoid the singleton implementation breaking, we'll need to throw an IO exception in the write object so that we can not allow user to store our instance in a serialization. And in read resolve object, we can return an already created instance, or it will return null if it is not initialized. There is also a scenario in which the singleton implementation will break is the reflection. So let's see how reflection will break the singleton implementation. So for that, I have created a reflection singleton class. It will implement our singleton implementation. So to avoid the multiple creation of the singleton class, we'll need to throw an exception if the instance is already created in the constructor. So we'll comment out this code and see how reflection will break our singleton implementation. So for that, I have created the reflection singleton test, and in this main class we will get the instance of our singleton class through the getInstance method. So our getInstance method will only return an instance if it is already created, or else it will create an instance and assign it to the variable. Now through the reflection.get class, reflection singleton.class.get declared constructor, we can get the constructors that are available in the reflection singleton class. Now in the constructor, we can set the accessibility of the constructor. So here we have the private constructor, but we can change its accessibility by setting accessible true. And the constructor class of the reflection API is having a new instance method. Through that we can create an instance of the class. So here we are printing the hash codes of the instances. Now see, let's check if it is creating multiple instances or not. So as you can see, the hash codes of two instances are different, so it has created two different instances. So we can prevent the multiple creation of the objects through reflection by throwing an exception by checking in the constructor. So because the reflection API is instantiating our object by calling the constructor. So in constructor we are checking if the instance is not null, then throw an instance is already created by using the instantiation error. Now see if we are able to create another instance or not. So here we can see that we are not able to create another instance through the reflection. If you see, the error is here in the constructor.new instance. So